66 million years ago, dinosaurs were at the height of their power as the dominant rulers of the Earth. However, sudden environmental changes triggered by an asteroid impact drove them to extinction. But in fact, over the roughly 4 billion year history of life on Earth, such mass extinctions have occurred repeatedly. One contributing factor was the massive amount of carbon dioxide released during prolonged, large-scale volcanic activity. The extreme climate shifts that resulted, such as a rapid rise in sea and air temperatures, caused countless life forms to disappear from the Earth. The 5 particularly severe extinction events are collectively known as the Big Five. Today, some scientists are sounding an alarm that we may have entered a crisis that could become the 6th. More than 48,000 species are now facing the threat of extinction. Disturbingly, that number has increased more than 4-fold in just 25 years. The major cause behind this crisis is human activities, such as environmental destruction and pollution. In particular, the impact of climate change accelerated by greenhouse gases is said to be severe. IUCN, the International Union for Conservation of Nature, reports that approximately 16,000 endangered species are now being affected by climate change. Unlike the past crises, it is human activities that are threatening the 6th mass extinction. The Secretary-General of the United Nations, Antonio Guterres, delivered a stark warning.
Humanity has become a weapon of mass extinction. We are treating nature like a toilet.
To prevent the 6th mass extinction from becoming a reality, we consider what we must do now by learning from the past.
Hello, I'm Stuart Varnum-Atkin, and I've come here to the National Museum of Nature and Science in Tokyo, where an extraordinary and very thought-provoking exhibition is currently being held, titled Mass Extinctions Big Five. The invaluable fossils and specimens on display here tell the story of life on Earth over nearly 4 billion years. They reveal the reality of the 5 global mass extinctions that occurred over this vast span of time. And as we've just heard, scientists are now warning that we are on the brink of the 6th mass extinction. Today, by learning from the distant past, we would like to consider what we can do here and now. First, let's hear about the past mass extinctions from an expert, who was in fact the chief curator of this wonderful exhibition, and that's Dr. Yabe Atsushi. Dr. Yabe, thank you very much for coming today. Thank you.
Dr. Yabe Atsushi is the head of the Evolutionary Paleontology Division at the National Museum of Nature and Science. Specializing in plant macrofossils, he analyzes past growth environments and conducts climate analysis of temperatures and precipitation levels of the time based on their shapes and characteristics.
Could we begin with a question about the mass extinctions? What exactly does mass extinctions mean?
まず Well, Mr. Atkin, do you think extinctions are very unusual events?
Well, I know a little bit about extinctions, but not so much, yes.
Okay. In fact, extinction is a very natural process. We know that on average, roughly 10% of species go extinct every 1 million years or so. In contrast, mass extinction, where many species go extinct almost all at once within a relatively short geological time frame, is a remarkable event. The rate can reach as high as 70 to 90%.
I see.
So it's an extinction event severe enough to wipe out nearly all life on Earth. What exactly triggered such massive-scale extinctions?
We know that the largest of these extinctions, called the Big Five, were triggered by rapid environmental changes caused by phenomena originating from outside Earth or within Earth itself. This ancestor of mammals, including us humans, thrived during the Permian period. However, at the end of the Permian period, around 250 million years ago, marking the boundary between the Paleozoic and Mesozoic eras, a massive mass extinction occurred. As a result, it's believed that 97% of land creatures, including the Cotylorinchus, went extinct. And 80 to 86% of marine species went extinct. Such a mass extinction occurred at that time.
So what caused an extinction on that scale?
Let me explain just along here.
Thank you.
Please, look up there. Volcanic activity, right? It was so massive that it triggered a cascade of environmental changes. Among them, it's understood that the global cooling caused by volcanic activity, followed by a subsequent long-term period of large-scale warming, had an extremely significant impact on the biological world.
So what is the mechanism behind mass extinction? First, massive volcanic activity over a vast area released huge amounts of volcanic dust, gas, and lava over several million years. The dust blocked sunlight, triggering rapid global cooling. This was followed by very long-term global warming, driven by the greenhouse effect of released carbon dioxide. Sea surface temperatures rose by about 13 degrees Celsius over 800,000 years. In addition, ocean currents slowed, creating ocean deoxygenation. And as carbon dioxide dissolved into the seawater, the ocean became more acidic. It's believed this resulted in the environment becoming uninhabitable.
It's believed that such a chain of environmental changes occurred, leading to the extinction of both marine and land life forms.
So a huge mixture of causes over a long period.
Yeah.
I see. Events like these seem to belong to the distant past, actually, to have very little to do with us today. But what can we learn from the Big Five, would you say?
Well, that's a very good question. Although they are things of the past, we still don't fully understand the mechanisms of the Earth. So when something happens now, we often don't know what kind of impact it will have. According to recently published research, examination of the 5 mass extinctions reveals that temperature changes occurred over a relatively short period of time. For example, at a rate of about 10 degrees Celsius over 1 million years. Could this be one of the keys to mass extinction? Some scientists are convinced of that. Through such research, we believe we can learn from the past about the present.
Well, from past mass extinction events, we can see just how profound the impact of rapid environmental changes can be on life itself. And now the threat of the 6th mass extinction looms. How many species are at risk of extinction due to rapid climate change caused by human activity? Some shocking facts have been revealed.
The IUCN warns that major factors threatening species are caused by human activity, such as environmental destruction and overexploitation of natural resources. According to the latest IUCN Red List dataset assessing extinction risk, over 48,000 species are now on the brink of extinction. The number of species facing extinction has surged in recent years, with climate change being one contributing factor. Dr. Craig Hilton-Taylor, who has served as head of the IUCN Red List unit for 27 years, shares the shocking latest findings.
And currently, if you look at the Red List, almost 16,000 species are threatened by climate change to varying degrees. So we're not yet in a 6th extinction crisis, but we are heading that way.
In 2004, IUCN classified a species as extinct. This tiny amphibian called a golden toad was living in this nature reserve in Costa Rica. The reserve was a protected area said to be free of deforestation and water pollution. In a report by IPCC, climate change was implicated as a key driver. The toads were a case of extinction primarily caused by successive extreme droughts. Right now, as sea temperatures rise due to global warming, coral reefs are seriously under threat. A place where you can witness this reality firsthand is located at Miyako Island in Japan. Professor Yamano Hiroya has long been involved in coral reef surveys and conservation activities, diving into the sea himself.
ヤビジっていう場所があるんですね。でその場所は島から離れていますので、陸からの影響とかない場所なんですね。そういった場所で水温が上がって白化現象が起こってしまったと、非常にショックを受けたのを覚えてます。
When coral is bleached, it is in a weakened state. About 2 years later, much of it had been driven to death. An IPCC report has predicted that even if global warming is limited to 1.5 degrees Celsius, 70 to 90% of the world's coral reefs will be lost forever. And if temperatures rise by 2 degrees, the figure could reach 99%. Another place where the effect of climate change is particularly prominent is the Arctic Circle. This is a report by the Arctic Council, which monitors climate change in the region. It warns that warming is progressing at 3 times the global average rate. The National Institute of Polar Research has conducted extensive studies at the North and South Poles. They have been continuously observing the state of the polar regions via satellite data since 1979. This is a graph of the Arctic sea ice cover in winter based on their data. In 2025, the sea ice cover reached the lowest level ever recorded. And a simulation carried out by the Institute suggests that summer sea ice could disappear entirely by 2080. Exposed to that extreme environmental change is the polar bear, the largest land carnivore which has no natural predators. Sea ice is where polar bears hunt seals for food. If the ice disappears due to global warming, their nutritional status will significantly decline. A paper by PBI, Polar Bears International, and others revealed that the bear population in the western Hudson Bay in Canada has declined by 50% over the past 40 years. Moreover, according to a paper by Dr. Andrew DeRocha, who has conducted ecological research in the same area, 40 to 73% of pregnant females would fail to reproduce if the spring sea ice breakup occurs 1 month earlier than during the 1990s. Professor Tsubota Toshio of Hokkaido University, who has participated in DeRocha's ecological survey for many years, has witnessed the dire situation the bears face.
連れている子どもの数が昔であれば2頭連れているのが当たり前で、今捕まえるホッキョクグマのほとんどは1頭の子どもしか連れていないという状況で、氷がなくなったらホッキョクグマの運命としてはもう絶滅しかないと思いますね。で、ホッキョクグマが住めない地球環境っていうのはおそらく人類にとっても住めない環境になると思いますので、我々の未来を反映してるんだと思うんですよね。
The IUCN, which publishes the Red List, is sounding the alarm that human activity is significantly accelerating climate change, making the issue even more severe.
Although it's a natural event, if we look at what the Red List tells us, we see that currently extinctions are 100 to even 1,000 times higher than the natural background extinction rate. And this is all because of human activities. It's impacting every part of the planet.
We've invited another expert to join us here today, and here he is, Dr. Onuma Manabu. Onuma Sensei, welcome.
Dr. Onuma Manabu has conducted field research on the wildlife in Hokkaido and worked as a veterinarian in Malaysia. Since 2002, he has participated in projects at the National Institute for Environmental Studies, which specializes in global environmental issues. Currently serving as the head of a research project, Dr. Onuma stands at the forefront of biodiversity protection and is working to conserve endangered species.
Dr. Onuma, we've just seen how climate change can affect polar bears. Thinking about extinction risks, what are your impressions about this situation?
What impressed me most is the situation is the not future issue. That is the ongoing issues. So polar bear are very specialized to living in the iceberg field. So shrinking the iceberg is directly affected their lives and reproductions. So this is a typical case of the climate change affect the biodiversity.
Yes. So how do you think the current extinction situation differs from the Big Five?
One major difference is the extinction occurring present is driven by the humans. This is the first time of the Earth's history, one species, this means the humans, it causes the biodiversity loss. That is the big difference.
So when it comes to biodiversity crisis caused by climate change, is there anything in particular that concerns you at the moment?
In Japanese rock ptarmigan, do you know the rock ptarmigan?
Ah, a very beautiful bird, right?
Yeah,
in the mountains.
Yes.
Yes.
So the species is very heavy under pressure of the climate change. Now the vegetation of the alpine area in Japan is the shift. So their habitat vegetation is change. And then after the vegetation shift, the many other species also move to their habitat.
I see.
So there will be new species interactions. The moving to the species, including the predator of the species.
I see.
So this means the suitable habitat of the species is shrinking now. So this is my concern.
As Dr. Onuma points out, the effects of climate change are said to be particularly prominent in alpine areas. Spanning central Hokkaido, the Taisetsu Mountains include peaks reaching 2,000 meters. This is a location where globally rare alpine plants inhabit a single mountain range, and the variety of plant species amounts to over 350. Associate Professor Kudo Gaku of Hokkaido University has spent nearly 40 years researching ecosystems in these mountains. In recent years, he says that an anomaly has been unfolding in this sanctuary. In 1990, Narcissus anemone flowers blanketed the entire area in white. However, the scene changed dramatically when a local extinction occurred, and the flowers disappeared completely from the area. Why?
まず温暖化の可能性が一番高いと断定していいと思います。
Professor Kudo and his team have found that in the Taisetsu Mountains, annual average temperatures have risen by 1.4 degrees over the past 45 years. Kudo says that when rising temperatures accelerate snowmelt, the soil dries out and alpine species are replaced by plants that prefer dry conditions. In recent years, it's become clear that dwarf bamboo is increasing at an alarming rate. The red areas on this aerial photograph indicate the distribution of dwarf bamboo. In 35 years, its area roughly doubled, threatening the habitat of alpine plants. Rising temperatures are also having a serious impact on the relationship between alpine plants and insects. In the Taisetsu Mountains, about 40% of alpine plants depend on bumblebees for pollination. This graph indicates the number of flowering plant species by season. When the graph of bumblebee appearance numbers is overlaid, the peaks of both are nearly identical. But in 2023, when temperatures were unusually high and snow melted earlier, the peaks no longer aligned. Flowers bloom before the bumblebees became active. If this phenomenon, known as phenological mismatch, continues, it could lead to a serious situation in which the survival of both species is threatened. The impact is spreading to insects and animals that feed on alpine plants, and then to the organisms that prey on those species. This raises concerns about a cascading effect on the entire ecosystem.
これまで高山帯の中で維持されてきた生態系のバランスというものが大きく変わる可能性がありますね。それで多くの動物や昆虫、植物が絶滅していく危険性が大きくなります。
Dr. Onuma, what you were saying earlier about species being interconnected really came through in the video there. Do you feel this in your day-to-day research as well?
Yes. Yeah. In Japan, the deer population is increasing.
Ah, yes.
This is due to the wolf extinctions.
Ah.
Then increasing the population of the deer make the problems, especially the endangered plant. The deers, the heavily grazing the vegetations, and then the vegetation including the endangered plant. This is the example of the one species extinction affecting the other ecosystems.
That's very interesting indeed, yeah. So there's a kind of, I think you call it a cascading collapse, is that right, in ecosystems?
Yeah.
I understand there's something that makes today's situation even more serious. What is that?
Yeah. One thing, the serious thing is the extinction speed is very fast compared with the past.
I see.
So, of course, there is the mass extinction occurred before, But this extinction occurred over a very long time scale. So that's why one species extinct, but they have enough time to other species evolve or adapt the new environment.
That seems a very important point. So in effect, up to now, evolution has always gone hand in hand with extinction.
Yeah. But now the species don't have enough time to adapt the new situation.
I see.
So we are very concerned about these situations.
Thought-provoking items at the Mass Extinctions exhibition reveal why biodiversity loss is unfolding at such an astonishing pace.
We have a rather interesting exhibit here that shows traces of human activity etched into nature. So I'd like to show you that.
Oh, thank you.
This is it. It's a boring core sample taken from the seafloor in Beppu Bay in Kyushu. It's an extremely rare item. Year after year, layers of soil and silt were laid down at the bottom of the bay. Can you see the layers? They contain many different substances accumulated year by year. Analysis of the components within each layer has shown that by around the 1950s, elements like radioactive material from nuclear tests and microplastics began appearing. So various human activities are now becoming incorporated into these geological strata.
So what environmental effect do these kinds of human activity have?
Well, here is a rather interesting specimen. Actually, it's a replica of an Antarctic ice core. The ice in Antarctica is formed by snow being deposited each year. So it contains the air from each year. This means that from this core, we can analyze the atmospheric composition for up to 800,000 years. The actual core that was drilled out is longer than this. From the results, it's become clear that carbon dioxide concentrations have been rising ever since the Industrial Revolution. In addition, we can discover the origin of the carbon in the carbon dioxide by analyzing the carbon isotopes. What we've come to understand is that since we know fossil fuel origin carbon has lighter, stable isotopes, a high proportion of such light carbon indicates a significant presence of human activity-derived carbon in the sample. This kind of research is the basis for the Intergovernmental Panel on Climate Change to conclude that there is no space for discussion regarding the fact that human activity is the root of climate warming.
Well, Dr. Yabe, thank you very much for that splendid explanation. So, driven in part by human activity, the Earth's environment and ecosystems are changing at an alarming speed, and these changes are now affecting our daily lives.
Carrying pollen from flower to flower, bees act as pollinators. In 2025, IUCN announced its finding that 172 species of bees in Europe are in danger of extinction. One of the contributing factors is said to be rising temperatures from climate change.
夏場ものすごい高温になって、その高温が蜂の行動を阻害するっていうことはまずはあると思います。例えば幼虫やさなぎのその生育が正常に進まなかったりというようなことは考えられます。
Around the world today, the reduced number of bees is having a noticeable impact on fruit and vegetable cultivation. According to the Food and Agriculture Organization, more than 75% of the agricultural products we consume depend to some extent on pollinators such as bees. The impact is already spreading across Japanese farming. Hata Hiroki grows mini tomatoes in Gunma Prefecture. Over the last few years, bees have ceased to pollinate after the summer heat. What once began from mid-September has recently shifted to mid-October. When bees don't pollinate, farmers need to do the work manually. However, during the period of manual pollination last year, tomato yield dropped by 5%.
どうしても、受粉するタイミングを逃してしまったり、あと花自体が見つからなくて、その受粉作業できなくて、実にならなかったりとかっていうことも起こっちゃいますね。
So things that we once regarded as normal features of life are disappearing. Dr. Onuma, and I understand that an event which we have all experienced is also closely connected to this loss of biodiversity.
Yeah, actually the biodiversity have many functions. The one important function is providing the ecosystem service. So the ecosystem service including the providing of food, the clean water and clean airs, and then including the regulation of the infectious disease. So one concept was proposed. We call this the dilution effect. So if the ecosystem have the high biodiversity, the ecosystem the regulated infectious disease spreading. So if biodiversity loss, I mean the biodiversity is decline, the pathogen easily spill over from wildlife to the human or domestic animals. Recently we have the example of this case, the pandemic by COVID-19.
Right.
So this is one of the example how ecosystem regulated infectious disease. So now biodiversity is declining. So then this kind of the situation easily may happen.
I see.
So the other thing is related to the climate change and the biodiversity. The ecosystem is changed due to the climate change. Then we are worried about the changing occurrence pattern of the high pathogenic avian influenzas. The avian influenza carried by the migratory birds. Due to the climate change, the migratory route may change. And then the timing of the migration also change. So this means the spreading of the high pathogenic avian influenza pattern is changed. So we are also worried about these kind of things.
Wow, this is a very kind of deep subject. Everything is connected, right?
Everything are connected. But most people don't know about the relationship, the spillover of the pathogen and biodiversity loss.
That's really very, very interesting indeed. So to avoid such a worst-case future, governments and experts around the world are pooling their knowledge and efforts to address climate change and protect biodiversity. However, it seems that some well-intentioned measures can also end up causing harm to wildlife.
Wind power generation is rapidly expanding as a sustainable energy source. At the same time, however, it can be a threat to the lives of many birds. Wyoming, a key nesting area for golden eagles, is also now home to some of the largest onshore wind farms in the United States. There have been numerous cases of golden eagles colliding with wind turbine blades and losing their lives. The toll is estimated at around 270 deaths annually, a figure that has doubled over the past decade. Considering all types of birds, a recent study has estimated that nearly 700,000 are killed in collisions with wind turbines every year in the US. Seabirds are threatened by offshore wind turbines. In the UK, many offshore wind farms are already in place in the North Sea, powered by strong and reliable winds all year round. Black-legged kittiwakes that have long lived along these coasts are among the species now under growing pressure. Kittiwakes spend most of their lives out at sea. They nest on steep coastal cliffs and fly long distances to forage for small fish to feed their chicks. During the breeding season, kittiwakes typically forage within 30 to 40 kilometers from their colonies. But offshore wind farms now sit directly between the breeding colonies and feeding ground. Some birds regard the wind farms as barriers and completely avoid them. However, they end up flying further to reach the feeding grounds. Ornithologist Angus Cook comments.
They fly around the wind farm rather than straight through the area when they're trying to forage. So there's a potentially increased energetic cost due to having to travel further, and there's a potential for habitat loss and the loss of sort of key foraging habitat.
On the IUCN Red List, black-legged kittiwakes are listed as vulnerable. Against this background, an initiative began in the UK to create artificial nesting structures about 1 kilometre offshore. The first chick hatched there in the summer of 2024.
And it's really hard to say how effective these artificial nest structures are going to be. I think we need to wait and see what the evidence is.
Dr. Onuma, what are your thoughts on the dilemma between maintaining biodiversity and addressing climate change?
Yes, this is very difficult to answer. So, but we need to continue both climate actions and biodiversity conservations. So if we don't do anything in the both, the biodiversity loss is continue, and climate change also become more serious.
Thinking about the possibility of a sixth mass extinction, what do you think we should do now to prevent that?
This is also a very difficult question, but firstly, I have to say again, we should know the ecosystem provide us the many service, and then ecosystem with the high biodiversity provide more wide range of the ecosystem service. Firstly, we should know this. And then next, we have to pass the biodiversity to the next generation. I mean, we have to pass the biodiversity in the future. There is the one option is the cryopreserve the biodiversity. So that is our project. Is called Time Capsule Project.
Dr. Onuma's initiative is being conducted at the National Institute for Environmental Studies.
ここは細胞を液体窒素の中で、保存するためのタンクが設置されている部屋ですね。これが液体窒素タンクになります。
The tanks contain cryopreserved cells and tissues of wildlife, including endangered species listed on the Ministry of the Environment's Red List. The initiative aims to preserve genetic diversity for future generations. By preserving cells, research into conservation measures for endangered species may advance. The inside of each tank is cooled to around minus 160 degrees Celsius. The Okinawa rail is a flightless bird only found in Okinawa. It's classified as critically endangered on the red list established by the Japanese Ministry of the Environment. Cells are collected from the bodies of creatures that have died in traffic accidents or from other causes. They are sent in by collaborators nationwide. Today, another Okinawa rail has arrived.
翼の羽の付け根のあたりから皮膚を取ります。ここら辺がよく細胞が増えるということが経験上分かっているので。
The collected tissues are cut into tiny pieces. They are then placed in a culture medium and kept warm at around 37 degrees Celsius. Then, this black object is a living tissue sample. You can see how the cells divide and multiply from the tissue.
これを我々は増やした細胞を凍結保存しています。ここで培養を始めるまでに、そうですね、5日とか長い場合には1週間くらい死亡してから時間が経過した状態で細胞培養を始めるんですけれども、十分に増えています。
They have even cultured living cells from tissue samples refrigerated for about 1 month. This research work on extracting and multiplying living cells from bird specimens is said to be among the best in the world. The time capsule project also preserves cells from many other endangered species.
今だいたい絶滅危惧種でだいたい120種くらいですね。ツシマヤマネコもそうですし、オジロワシ、オオワシ、ヤンバルクイナ、それらもすべてこのタンクの中で保存されています。
They have already preserved cells of 127 species listed as endangered on the Ministry of the Environment's Red List, and aim to preserve a total of 385 of Japan's endangered species in the future.
事業の中で一番象徴的なのはやはり日本産のトキの細胞だと思うんですけれども、ここに細胞が二度と手に入らないといいますか、もう個体がいないので。
The Japanese crested ibis became extinct in 2003. The genetic information from the cells of the last bird has been preserved for the future.
細胞を使った研究がいろいろ応用範囲が広がってきてるんですね。非常に大きいインパクトがあったのはiPS 細胞を樹立できる。
Dr. Onuma and his team succeeded in creating iPS cells using preserved cells. iPS cells can be turned into various different cell types. In 2022, for the first time in the world, iPS cells were created from 4 endangered bird species, including the Okinawa rail and the Japanese rock ptarmigan. Although there are many issues to be tackled, the project is working to connect this research to future efforts to breed endangered species once again.
Well, Dr. Onuma, this is a truly remarkable initiative you're involved in. I'd like to ask you, what do you see personally as the significance of the time capsule project?
Significance of our project is we cryopreserve the live cells. So sometimes the people keep the sample of the endangered species, but most of the cases is the sample is fixed by ethanol or formalin, or this means the tissue is dead. But our cell is live cell. This means we cryopreserve the feature of the species. This is the big difference between usual tissue preservation. This is a big feature of our project.
So is this a kind of final safeguard, is it?
Yeah, I agree. That is we can say this is the final safeguard. But we have to do something before reach to the final safeguard.
Indeed.
So for example, conserving the habitat and maintain the captive population in the zoo. And then our activity, the project is the final safeguard. I try to make effort to maintain this project, but actually I don't hope this material use for the population recovery in the future. Of course, I continue, but ideally, there is the future without the utilization of the cryopreserved materials.
You're at the forefront of this kind of work, so can I ask you, do you have a message for our viewers about the threat of the 6th mass extinction?
I think most people don't fear the mass extinction now. But recently we cryopreserved one small beautiful butterfly species. That we call this the Ogasawara shijimi, distributed only in the Bonin Island, Ogasawara Island. That is an endemic species, that areas. And now we can observe the wild population in the island. Then we accept the germ cell of the species. So when I see the germ cell of the species, I think, this is the extinction. Of course, this is not yet almost extinction, I could say. But this is the extinctions. So at the time, I think the extinction occurs overseas or just textbook. But I think, this is extinction happen next to me.
Yes.
And then I handling the last evidence that species exist on the earth. So I think the extinction is not the future story. The extinction occurred next to us. This is the message from me.
Well, thank you very much indeed for joining us today, and we wish you all the best with your initiatives.
Yeah, thank you very much.
As we've heard, the chain of extinction is unfolding before our eyes. Let us fervently hope that 10,000, 100,000, or even 1 million years from now, we will be remembered by humanity as the people who somehow or other managed to prevent the 6th mass extinction in time to save the Earth. Thank you for joining us today.